Hello and welcome to part 3 of the first steps in steel construction. In the first step, or in the first two parts, we have now modeled the cardboard, and now I would like to move on to the evaluations. For this, it is especially important to me that the sheets for the gutter get a front view for the workshop drawing. That means you can see here on this cube that the front view would now be the top side. However, I would like to change this manually. Here I can select the front view for all gutters, and if I look at the cube again now, this would be the front view for the workshop drawing. This only has an impact on the workshop drawing for beams, or in other words, beam constructions. It is fixed there, as the orientation of the workshop drawing comes from the so-called main assembly part. In the next step, however, I would like this gutter to be welded together. That means I still need to form an assembly here. The assembly is actually to be seen as a welded assembly, gutter with drain. I give this a name, and can also define usage types here. These usage types are basically and essentially necessary for the workshop drawing. These usage types can also be independently expanded and changed from within. So next I will take a look at the structure, and I can, for example, also check the beams to see if they have these usage types. In this case, you can see that they have the usage type assembled beam, which usually produces very nice drawings in beam constructions. So that means my model is finished in this regard, and now I first switch to my sheet area. HiCAD has first gone to the top view. I can now, of course, manually edit this further and could add a drawing frame as the first step. In the first step, I change the representation, and now I don't want to work with 4 standard views as in the first video, but I want to define and store them manually. You can still see here that I have enabled the option for active view only, which I will now deactivate again. Now I would also like to have a section where I can see the floor plan. For this, I again select with underlying parts and immediately have my section view here. Of course, I can add the dimensioning here at any time, meaning I want to have the axis dimensions of the beam here. Here, I have selected the wrong point. This means I can, of course, change it at any time if, as in this case, I have selected the wrong point. Now I have picked the wrong one again. So that means I have my views here. I would like to create a detail from a base plate. If you want to make the scale larger, or rather smaller to be precise, actually, I would also like to generate a detail, sphere, cuboid from a certain area, specifically from the node. That means I specify the center point here, draw this cuboid to my desired size, define my scale as 2001 again, and place it here. So, now it is important to know that all these views are 3-dimensional. I will move them up a bit more, meaning I can also display them here in a shaded view or pull them into 3D. Of course, I very often use a variety of visibility options here as well. That means I basically want to make these parts transparent in this view to see better behind them. Even this detail is 3-dimensional. You can see it better when it is shaded. Of course, I can also leave it in this representation and adjust this detail as I see fit. Of course, you can also display the tangential representation edges here to make it look a bit better visually. So, next I need to define my view as well, meaning my plan content. Since I did this with Helios, I need to enter my values here. For example, once I have entered these values, I have the option to update this and it will be immediately recorded here. So, the next step would be the identical part search, which means HiCAD naturally supports me with an automatic identical part search. I can start this here via construction. Here, when I click on the automatic identical part search, it would start the identical part search. However, I would like to use the options, meaning I want to enter the dialog to show you what possibilities there are. For this purpose, I have defined a filter that also generates position text for me in this case. In this case, the position texts are such that assemblies get a BG prefix, profiles, get a PR prefix, and sheets, for example, get a BL prefix, and it continues like this, with glass getting a GL prefix, and so on. This can of course be completely defined manually, and with OK. HiCAD has generated my identical part search. You can see this on the parts here when I click on one of these numbers. All identical parts naturally receive the same position numbers, and HiCAD then naturally consolidates this for me. The first and often one of the most central steps is the bill of materials. Here, I can click on the bill of materials, and in the first step, I could select various variants and bill of materials templates. However, I simply want to transfer this to the report manager, and I do this here by clicking OK. Now all values are generated in the parts list, and you can already see a summarized list here. The best way is, of course, always to transfer to Excel. I just need to simply press the button and HiCAD generates my Excel list. So, this Excel list is divided into different tabs, in other words, worksheets. Here you can see a structure list that defines all assemblies with their corresponding individual parts and screws. A quantity list where everything is sorted by position number. A list where all profiles are summed up. And a cutting list where you can also see the cut symbols. This list is only for sheets. Then of course there are also lists for bench sheets, where you can see the sheets with the cross section in different variants. The screw list, which naturally includes all screws, and the shipping list are often important. The shipping list, where the assemblies with pictures are used, can be very well utilized for shipping after assembly, but also for the galvanizer. There is also a short form of this list, where only the number is present with the picture, and then there is the profile bar list. This profile bar list is actually an optimization, where I can see, for example, with the HEA 180, I need a bar with the position number, cutting 100 twice, and thus this bar is utilized. So a profile bar optimization. And finally, there is the summary, which means what do I need to order in this case. Of course, I can also differentiate this Excel list into a quantity list and a structure list, and it can also be exported to the plan. So I immediately have a list on the plan. I see now that I haven't sorted the position numbers here, so I just click on it once and then click on HiCAD again, and the bill of materials is immediately sorted by the position numbers. So, in this case, I have taken the first steps here. Of course, I can also label the parts here at any time, which I can do according to various criteria. Either I have the option here to use a predefined filter for the position number or a labeling template, as I should correctly say, or I can define by a part type where I can specify the criteria for labeling the parts. That means I basically just need to click on the parts as I need them and have all the information which I can continue to easily edit on the plan. This bill of materials, or this labeling, is very easy to edit. Via the attributes, I can manually influence it and also easily store it. So the next step would naturally be the drawing. For that, I need to click on Save. Here, since I work with Helios, all my article masters and drawings are generated here. And now, here in the ribbon drawing management, I have the option to click on Drawing and all drawings, or all parts that do not yet have a drawing are listed here. I will just take a few profiles here, just to see a bit. So profiles, sheets, 1 or 2 assemblies, just to see a bit what comes up. For me, it is set up so that each individual part goes on a plan and each assembly goes on a plan, so that I can more easily ensure the traceability of all the parts. You can also see here at the bottom left that I have set it so that the scale is adjusted to the frame size. In other words, I have predefined my frame size for the individual parts, and HiCAD selects the best possible scale for me. That would be one possibility. Or of course I can also say that certain parts should come to a fixed scale. This is mainly done when I have many individual parts on a plan. Then you specify, okay, it should, for example, all beams should be drawn to a scale of 1 to 10 and all sheets to a scale of 1 to 5 on the plan. In this case, with this profile 102, it was briefly shown that I set it to place this on an A. And the scale is obviously much too large for this. That means I take this profile. And of course, since it is linked with HiCAD and Helios, I can jump into the workshop drawing at any time and modify it afterwards, because it has come onto frame A and is now obviously much too small. For this, I can simply go ahead and say, okay, I don't want this profile on A, but rather on A as an example, and the scale should still be adjusted. At the bottom left, you can see that the scale now drops down. And this is simply because there are so many drillings, 2001, which are labeled here. Of course, I can also go ahead and say, okay, I do not want to label these drillings. I can adjust this here at any time individually or separately. Normally, it is set as a standard, but in this case, with this beam, it is rather extremely confusing. By saving, the file is naturally saved again here, and my PDF is also automatically generated. In other words, when I view my project in Helios, I also see my PDF here, for example, the 102. When I go to the preview of this PDF here, I can immediately see that this PDF is up to date. It is also important that you can immediately see which assembly this individual part belongs to. That is why one of the most important points for me, and why I like 2001 so much, is that every individual part is on a plan, because the plan number, for example. At the same time, it is also the position number. This way, I can find my parts much more easily. Of course, I can go ahead and say that I want a certain assembly when I take further options of the drawing. In this case, I will take this assembly and these parts. I want to include the active assembly. Along with the auxiliary parts here, I want to make these parts, or I want to make these on individual bills of materials and drawings. Thus, all parts belonging to this assembly are placed on the plan, and therefore this assembly, along with all the individual parts, has the plans. The next step that I would like to show a bit here is that when I go ahead and say certain parts are finished, I naturally have the option to check via the workshop drawing whether this workshop drawing is correct for this support, and can also, for example, say that this support would be released. Now, with this release, all the necessary production relevant data is generated for me, and HiCAD has also locked this part for me, which is of course very important for further processing, since this part is now complete. That means if I want to make a change because I forgot something, I cannot do it, as this part has been locked. Of course, I always have the option to change this. And if I click on change here, I can define my change text, i.e. index text, and HiCAD will generate an index for this part again, place it back into the work step, in progress, and thus I can continue to edit this carrier at any time. This way, I also have control, so that when I have given parts into production, I always have the current status. This was of course just a very small and brief insight into what the workflow can be like. I hope you enjoyed it and can derive some value from it.